For 12D and E here, it's best to compare them to reflecting over X equals a concrete number like you have in B. And for E, it's best to compare it to what you did when you reflected over Y equals 9. Because that will help you figure out, okay, what did I do to actually do that reflection? And let's do it instead with 9 and -1. Let's do it with T and N. So let's take part D first. And by the way, the first thing that is really helpful is to just draw this sketch what this parabola looks like. It has a vertex, and it's really about sketching the vertex and the direction it's opening. So the vertex is at 5, 3. And let's go over what we did when we reflected it over the line X equals -1. And then we'll do, okay, now let's talk about when X equals N, so some generic. So when we did X equals -1, what you had to notice is when I'm reflecting over that line, the vertex is going to be equidistant now to the left of what it was before. So here, to find what that distance is, what I would do here is I'm just finding this distance. Remember this here, let's just put in what this point was. It was 5, 3. So to find this horizontal distance, I did 5 minus -1. So I did 5 minus -1, which got me 6. And then how I put that on the other side is to make sure the distance was the same. I did -1 minus 6 because I want it to be 6 away in this direction here, right? Because these distances have to be the same. So this also has to be 6 if this side's 6. Well, let's do that then for the generic X equals N. And let's remember what we did here. So before we took that 5, the actual vertex, let's do a different color here. We did 5, and then instead of subtracting -1, we're gonna subtract some generic N. So 5 minus, I don't need N to get that distance between the vertical line and the vertex. And I'm gonna take that distance, and like we did before, that instead of it -1, I'm gonna say N minus 5 minus N. And that's gonna be where my new vertex is. So combining like terms, distributing here, I get 2N minus 5. So now the only thing that's changed, remember, for part D, so for part D, the A value is the same. So I'm going to say A of X. Actually, I won't call it A of X because it's not the same function. I'll just say Y equals. So Y equals 2X minus this new vertex, which is 2N minus 5, this new X coordinate of the vertex, I should say, and the Y coordinate of the vertex has remained the same. So again, figuring out what I did with -1 and replicating that with just generic N. Let's do the same for part E. Let's first look at what we did for part A in this case, I guess it was. All right, let me do a little bit of erasing here to get some room. Oh, I didn't mean to erase that. Okay, this is 5, 3. I'm just gonna erase the things I don't need, so it's, all right. I don't know why that's not erasing here. Let's try this one more time. Oh, there we go. Okay. I just want to make some room here. All right, so now let's talk about reflecting it over what we did when it was 9. So notice we're at 5, 3. So let's do at 9. All right, so up at 9, let's do y equals 9. And here, what has changed is if I'm flipping it over y equals 9, now it's this vertical distance that's changed, and also the sign before the a value, because it'll be opening down. So to figure out what it was, we did in this case, I did 9, let's do a different color here, 9 minus 5 to get that distance. And then from that distance, I made sure to, in this case, I added it to the, in the other direction, so above. Or we could do, so say you wanted to, like, remember before we started with the y coordinate of the vertex. Actually, let's scratch this because I did use the x coordinate of the vertex. So let's start from the beginning again. So of this. So again, we're interested in this vertical distance here because that's what's going to change. So this vertical distance between the line y equals 9 and 3 is 6. But how do we get that? Well, we could say, in this case, I could say 9 minus 3, which of course gives me 6, and then add that to the 9. So I could say, all right, so in the other direction, I want to do 9 plus 6. So let's see if we can do that for the generic y equals t. So let's see what we did. We could say, and this is for the y coordinate of the vertex, we could start with our t and do t minus 3. And then you're going to take that and add it to t. So the new y coordinate of the vertex would be 2t minus 3. So for e, I'd have y equals, remember it's going to open down. The x coordinate of the vertex stays the same. And then the y coordinate would be 2t minus 3.